Alright, so here we are. This is Unit 11, I guess it's a Lesson 6. We're gonna basically we just finished with the alkanes, and we went through sort of miscellaneous properties or characteristics of the alkanes and then how to name the straight versus the branched. We're gonna do the same here with the alkenes. If you remember, the alkenes are unsaturated hydrocarbons. They contain a double bond between carbons. They can contain more than one double bond, but in this course, for the most part, alkenes are going to have one double bond between adjacent carbons, and the rest of the bonds between the carbons will be singles. The general formula is here. The names of all alkenes end in ene, whether they're straight chain or out branched. And basically, the easiest way to recognize the alkenes is that there are always twice as many hydrogens as carbons. Now, if you look at this formula right here, or this structural formula right here, you notice that, of course, because there's a double bond, there's a little bit of a difference in naming it. We didn't have to worry about this double bond in the alkanes because they're all single bonds. Once you get at least 4 carbons in an alkene, that changes or adds something to the naming of it. It doesn't with this, but we will get to that. So let's just quickly run through. If I gave you this formula, the structural formula, and you had to name it, first thing you're going to notice, it has a double bond, so you know it's an alkene, so right away you're going to know it's ene. We can all see it's a straight chain. And then all you do is you count the number of carbons. It's 1, 2, 3, and you're going to use the same prefixes that you use for the alkanes. This would be propene, and that's pretty much it. And this would be N-propene because it's just normal straight chain alkene called propene. It is possible when you have more than 3 carbons to have the double bond in more than one spot. I'll give you an example. I think that is what they are showing you down here. So let's quickly run through this. Since we're not going to worry about the alkenes with 2 double bonds, we're not going to worry about that. They're called dienes. Let's take a look at this one. I'll show you what I mean. Notice that, again, it's an alkene. It has a double bond here. It has 1, 2, 3, 4, 5. So you know it's based on the prefix pent, and it ends in ene. And you might say, okay, well, that's it. It's pentene. Well, here's the problem. The double bond is here in this particular case, but it could also be in a different location. I could put the double bond here. You can't call both of them pentene because the double bond's in a different spot. So when you start with an alkene that has at least 4 carbons, you have to, in addition to naming it with the prefix and then the ene ending, you also have to indicate where that double bond is. But you don't do that if the alkene has less than 4 carbons. If an alkene has 4 or more carbons, in addition to the name, you have to indicate where the double bond is. And you have to put it so that it's between the lowest numbered carbons. So if I number it in this direction, that would be the first, second, that would be the third, and the 4th carbon. If I number it in this direction, it would be between the second and the third. That would mean that I'm going to number it in this direction, so it's between the second and the third carbon. So I'm just going to put the 2 for it. And that would be 2-pentene. That 2 tells me that there's a double bond between the second and the third carbon in the chain. Okay, now you might say, well, why don't we do the 3 and the 4? Because if you number it in this direction, that's going to give you smaller numbers, and you should always number it so that, in this case, the double bond is between carbons with the smaller numbers. If the double bond was here, all that would change is that this would be a 1-pentene because now it's between the first and the second carbon. Okay, but remember, if it's 4 or more carbon atoms, you have to indicate where the double bond is with a number. If it's less than 4 carbons, you don't have to worry about doing that. Now, it is possible, of course, because again, this is chemistry, to have branched alkenes. And I'm going to quickly, now they don't give you a lot of these on the Regents exam. They do give you alkanes a lot, so I'm not going to spend a lot of time on alkenes and even less time on alkynes. But I do want you to be able to figure out how to do these. So let's go through this. So branched alkenes are similar to the alkanes. They have a branch, so you have to find the parent chain, which of course has to include the double bond. You do have to, if it's 4 or more carbons, you do have to indicate where the double bond is, and then you have to name the branches just like you did before. So if you look at this one here, you're going to notice there's a double bond. I want to find the longest continuous chain that contains the double bond. So I know I'm going to start here. That's 1, that's 2, that's 3. Now I have two options. I can go straight or down. Either way, that's going to give me a 4-carbon chain, which is bute, and it's an alkene, so it's ENE. Now the double bond, I don't want to number it in this direction because that will give me the double bond between the third and the fourth. If I number it in this direction, it's between the first and the second. I'm going to call this 1-butene. So here is the parent. Now notice I have two methyls. I know that's going to be dimethyl. Dimethyl 1-butene. And you have to put a number. So that's between the second and those are on the second and third. So this would be 2, 3, dimethyl 1-butene. Okay? I know that's complicated. Let's quickly run through and do the alkynes also. Alright, so the alkynes, and I'm not going to read through this. This is stuff. They're already unsaturated. You know they have one triple bond between carbons. Here would be an example. It has 1, 2, 3 carbons. So again, it's based on prop. But now because it's an alkyne, it ends in Y and E. Now the same rule applies for the triple bond. If there are more than 3 carbons in the chain, if there are 4 or more carbons in the chain, you have to indicate where that triple. Now if you look at this one on the right hand side, you're going to notice that it has 4 carbons in it. So that means that there's more than one spot for this triple bond. It could be between these 2 carbons, or it could be here or here. Keep in mind whether it's here or here, it's the same exact thing because you could just flip this compound around and it's going to be the same thing. So this is between the second and the third. It has 4 carbons in it, so it's going to be 2-butyne. Okay, so let's go through. We already know how to do. These are just straight chain alkynes. It's 1, 2, 3, 4, 5, 6. So no matter what way I number it, it's going to be between the third and the fourth. So this is 3-hexyne. This is going to be 1-butyne. Okay. Alright, so here we have something different. Now, they've given you the name and they want you to draw the structure. Well, that's actually easier because let's ignore the 2 and let's do pentyne. Pentyne means there's 5 carbons. 1, 2, 3, 4, 5. The 2 means that the triple bond is between the second and the third. Well, the second and the third would be, here's the second, here's the third. Doesn't matter if I do this to here, that's the second and third, because remember, these are 3-dimensional. I could just flip it around. I'm going to put the triple bond here. 1, 2, 3. I fill in the rest with single bonds. You also have to keep in mind that every carbon has to have 4 bonds around it, which means that tells you how many hydrogens you have to add. So this carbon has 1 bond, so it needs another one, and another one. Those would be H's, and you don't necessarily have to write them. This carbon already has 4 bonds. 1, 2, 3, 4, so it's no hydrogens attached. Same thing here. This carbon has 2 bonds, one here and one here, so it needs 2 H's also to complete the 4 bonds. This carbon has 1 bond, so it's going to need 3 H's. Okay, and so you can see that that's what the structure would look like. Well, what about branched alkynes? And again, not going to spend a lot of time on this, but it's basically the same as you would do with the branched alkenes. You want to find the parent if they're given a structure. Make sure the parent includes the triple bond and do the branches thing. So let's do this one first. Let's ignore the 2-methyl. Let's do this part. 3-pentyne. Well, that tells you that there's 5 carbons. 1, 2, 3, 4, 5. It's also telling you that the triple bond is between the third and the fourth carbon. Okay, that doesn't make sense. Pentyne is 5 carbons. If it's between the third and the fourth, that would be here. So that's actually incorrect. Not quite sure what to do with that one. Let's cross that one out. Unless I'm missing something, that is incorrect. Let's go through and do this next one here. Oh, that one's just crazy looking. How you can even figure that out? Let's do the longest continuous chain. Is 1, 2, 3, 4, 5. Here's the triple bond. 6, 7. Now if I go this way, that's going to give me 8, but if I go here, that's going to give me 8, 9. So that's going to be, and yes, this is weird, no 9. And the triple bond is between the 1, 2, 3, 4, 5. So that's between 4th and the 5th, so it's 4, no 9. And it looks like I have 2 methyls here and here. So I know that's going to have to include dimethyl. Since this is the 4th carbon, the methyl group's attached to the 3rd, and 4, 5, and 6. So this compound is 3,6-dimethyl-4-nonine. Whoa! Hello. Alright. Let's do the last 2. Alright, let's ignore this and let's do 1 butene. Butene is 4 carbons. The triple bond is between the first and the second. 1, 2, 3. These are single bonds. And there's a methyl on the 3rd carbon. 1, 2, 3. Doesn't matter whether you put it here or here. I'm going to do this. CH3. Now you fill in the rest. This carbon has 3 bonds, so it has to have another hydrogen. This carbon already has 4. This carbon has 1, 2, 3, so there's an H here. And then this last carbon has to have 3 more hydrogens. Oh, God. I finally figured out how to do it. Okay. And that's an H. Okay, next one. 4-methyl-2-hexyne. Let's do this. Hexyne is 6 carbons. 1, 2, 3, 4, 5, 6. The triple bond is between the 2nd and the 3rd, so it doesn't matter whether I go here or here. So that'd be, it's 1, 2, 3. The rest of these carbons have single bonds. I have a methyl on the 4th carbon. 1, 2, 3, 4. It doesn't matter whether I put it here or here. I'm going to put it at the top here. That's CH3. I'm going to fill this in very quickly because you know how much this is getting to be too long a video already. Okay, that's that one. Let's do this last one. You have heptine. That's 5 carbons. 7 carbons, I should say. Whoop, hello. Okay. Okay, so let's move this up a little bit and over. Okay. So we have 5 heptine. Hept is 7. There's 1, 2, 3, 4, 5, 6, 7. And it's between the 5th and the 6th. So that's 1, 2, 3, 4, 5, 6. That's incorrect because if it's between the 5th and the 6th, you would actually number it 2, 3, and number it 2, 3. So I'm going to cross that one out too. I think there might be a mistake with that one too. Alright, so I think this lesson's probably long enough.